Hello everyone and welcome to lesson 6 of our CATIA V5 Part Design. Today we're diving into one of the most essential tools in any mechanical design, the hole command. This tool is far more powerful than a simple pocket, allowing us to create precise standard holes with custom positioning and tip shapes. Let's open up CATIA and start mastering this feature right now.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me.
Hello everyone. Today we want to talk about a tool called hole. To use this tool, like the pocket tool, we must have an initial volume. First, I go to the sketch plane and draw a rectangle. I fully constrain it. I return to the part environment. With the pad tool, I turn it into a rectangular cuboid. Now, I want to create a hole on its top surface. One initial way you learn was to select the top surface, go to the sketch environment, draw a circle with your desired diameter, Note that you can change its dimensions and location on the surface whenever you want. Return to the part environment. Create a hole with the pocket command. I will slightly change the transparency of the cuboid. In the design tree, I right-click on Pad 2. I select the Properties option. I click on the Graphic tab. In the Field section, I slightly move the transparency slider to the right. Now the cuboid is translucent. You can see the hole we created using the first method. I right-click on Pocket 1 in the design tree. I select Properties. I activate the Graphic tab. In the Field section, I click the V symbol next to Color. A color selection menu opens. I choose a suitable color. I click OK. Now let's talk about this green hole. The bottom of the hole is flat and does not have a conical shape. The upper edge of the hole is simple. Its size and location can be changed. The hole diameter must be entered manually. The hole does not have threads. To thread it, we must do it later with another tool. But for our convenience, the software has provided another tool called Hole. I click on the Hole tool. Nothing happened now. Now I have to click on the surface of the cuboid. I move the mouse over the surface. The mouse pointer turns into a hand. I click wherever I deem appropriate. The surface turns orange. The location for creating the hole on the cuboid is displayed. The hole definition window also opens. Look at the top of the window. You see 3 tabs with different names. The first tab, which is currently active, is called Extension. The parameters of this tab relates to the shape of the hole produced by a drill bit. The second tab is called Type. The parameters of this section relate to the shape of the hole's head. The third tab is called Thread Definition. In this section, parameters related to the thread are recorded. I click on the Extension tab. In the upper right of the window, you see a schematic shape. The shape you see in this tab is a simple hole. If you look above, under the tab, you see the word blind. A V symbol is placed next to it. Look, now that the shape of the hole is a blind hole, 3 parameters indicated by yellow dimensions in the schematic are definable for the hole. The first parameter is the hole diameter. You can enter its value in the diameter section. I double-click inside the box next to it until it turns blue. I type the number 15. The second parameter is the hole depth. You can enter it in the box next to depth. 2 other parameters are inactive in the blind state. The third parameter you can change is the shape of the drill bit tip. Drill bits primarily have a conical tip. The angle of drill bit tips varies. Now pay attention to the bottom section. Below it, V bottom is written. This state is the default state. Below it, there is an option called Angle. In the box next to Angle, 120 degrees is written. I double-click in this box. I type the number 90 in it. Sometimes it happens that we want the bottom of the hole to be flat. In this case, click on the V symbol next to the V bottom. Another state called Flat is selectable. If you select this state, the bottom of the hole is shown as flat. Note that by selecting this state, the angle option becomes inactive. I maintain the 90-degree state. There is another section at the bottom of the page called Direction. Generally, created holes are perpendicular to the surface. Sometimes it becomes necessary to create an oblique hole with a specified angle. If we uncheck Normal to Surface, in the box below it, we must introduce a direction to the software. I click the Cancel button. By selecting the side surface of the cuboid, I enter the sketcher environment. I draw a rectangle. I return to the part environment. I pocket it. I want to continue the pocket to the opposite side. In the Type section, I click the V symbol. I select the Up to Next option. The software understands that the next surface is the opposite surface. A preview is also shown to us. I click OK. The groove was created. I set the view to isometric. I click on the Fit-Align tool to have an appropriate zoom. I activate the Hole command. I click on the top surface where the groove exists. The Hole definition window opens. A preview of the hole is also shown. I click the V symbol next to Blind. I select the Up to Next option. You see that the Depth option became inactive. Another option called Offset is active. Our schematic shape also changed. In the schematic, you now only see a diameter dimension. The software moves the hole to the second opposite surface and creates it. Now I click on the V symbol again. I select the Up to Last option. Pay attention to the schematic shape. The hole has been drilled to the end of the volume. I click the Cancel button. Suppose one corner of our cuboid is chamfered. I click on the Hole command to activate it. I click on the surface of the cuboid. Below, I uncheck the Normal to Surface option. Note that the hole state is blind. The box below Normal to Surface has turned blue. No selection is written inside the box. I select the chamfer edge. By doing this, I introduce to the software the direction in which the hole should be drilled. Note that this direction can be any other direction as well. You see a preview of the shape on the screen. I change the blind state to Up to Next. I click OK. You see that an oblique through hole was created. I click on the Hole command again. I click on the top surface of the cuboid. Look, so far we have only specified the diameter and depth of the hole, but we must always specify the location of the hole creation as well. To do this, in this state where we see the hole, we click on the Positioning Sketch command. We are transferred to the sketcher plane. On this plane, the center of the hole is shown as a point. I place my mouse pointer over it. You can see it. Now I click on the Constrain command. I select this point and one of the edges. A dimension is produced. I do the same again with the other edge of my volume. You see that our point, which is the center of the hole, turned green. I return to the part environment. Two positioning dimensions are also displayed. I click OK. The hole was created with the specified diameter and in the specified position. Another and second method for positioning the center of the hole. First, I click on the hole command. Then I carefully click on the adjacent edges of the top surface of my volume. Third, I click on the top surface of the part. Now a hole with a specified diameter and height and with a specified position is displayed. I click OK. The hole was created. In the design tree, I double-click on the last drawn hole. Its settings window opens. The dimensions are also displayed on the shape. If I double-click on any of the dimensions, its constraint definition window opens. In the box next to the value, the amount of the dimension is specified. The dimension is blue. Without doing anything, type your desired number on the keyboard. Press the OK button. The hole moves. Now I click on the top surface of the cuboid. I go to the sketcher environment. I draw a circle. I draw the circle such that half of it is outside the cuboid surface. I constrain the circle and return to the part environment. I activate the path command. I click the reverse direction button to reverse the extrusion direction. In the type section, I activate up to plane option. The limit box becomes active. I click the bottom surface of the cuboid. I click OK. Now we want to create a hole that is concentric with this semicircle. I click on the hole command. First, I click on the edge of the semicircle. Note that you should move the mouse such that only the edge is selected. Then I click on the surface of the semicircle. A preview of the hole is seen. I click OK. In this case, the hole will be concentric with the semicircle. Well, the first part of the hole command is finished here. In the next lesson, we will review the second part of the command together. Watch the lesson twice. Practice with me the second time. Good luck. Until the next lesson, goodbye.
Let's build the future. Come with me. Don't